dear friends, in this class we are going to discuss, simply we are continuing the discussion on structural elucidation of morphine. In the last class we have discussed many points and we have arrived at a conclusion on the nature of two hydroxyl groups, what we have in your morphine, and there is uncertainty over the third oxygen, the presence of the type of functional group, whether the oxygen is in the form of what nature oxygen. The third one is we didn't discuss, and apart from this, the tertiary nitrogen, the position of nitrogen in the tertiary position, whether it is really in the tertiary or secondary or something else, we didn't discuss. Those points we'll try to discuss in this classroom. We know that there are three alkaloids, morphine, that is opium alkaloids. One is morphine, another one is codeine, and the third one is thebaine. In the morphine, the two OH are prime. There are three oxygen, we know. One hydroxyl primary, second hydroxyl secondary, and the third one, what we have concluded, is ether-linked oxygen and nitrogen in the tertiary. Similarly, in the codeine also we have the same structure, almost the same. The only difference compared to morphine is one of the hydroxyl is OCH3, another one OH, secondary alcohol, no difference. Nitrogen again in the tertiary position, and in thebaine there is one, both OH, there is no OH, both are OCH3. These are the things we have discussed. As far as last class is concerned, that you please refer my previous video, structural elucidation of morphine, part number 1. As I said, we have discussed the two functional nature of oxygen atoms. One is primary hydroxyl, another one is secondary hydroxyl, and the third one probably in the ether link. We further know that all the three alkaloids are tertiary bases. All the three are tertiary bases. Hydrogen in the tertiary position. All the three are bases. How to confirm this? Each codeine, morphine, and thebaine, each reacts with one molecule of methyl iodide, gives you meth iodide. The first confirmation is morphine, codeine, and thebaine reacts with one molecule of methyl iodide, gives you meth iodide. That is, in NCH3, nitrogen is connected with the ring structure. Whether the nitrogen is in the ring structure or something else, that we will discuss later. This portion reacts with methyl iodide, gives you meth iodide. Just one molecule of methyl is replaced in this reaction. This confirms that the nitrogen is linked with just only one CH3, nothing else. Nitrogen in the tertiary position. This reveals that nitrogen in the tertiary position. The nitrogen atom is in the tertiary. Nitrogen atom is nothing but tertiary nitrogen, what we have in all the three alkaloids. We have further proof to confirm this. When heated with hydrochloric acid at 140 degrees Celsius under pressure, morphine loses one molecule of water, gives you apomorphine. Morphine treated with 140 degrees Celsius under pressure. Morphine loses just one molecule of water, gives you apomorphine. Remember, this is apomorphine. One molecule of water less compared to the previous one, morphine. Therefore, its basic formula, the basic formula is 1H2O less compared to morphine. And as far as codeine is concerned, codeine also gives the same product. That is one water molecule less compared to your morphine. Whereas thebaine, it behaves differently. When thebaine is treated with dilute HCl, remember, thebaine is treated with dilute HCl, gives you a product, namely thebanine. And this thebanine molecular formula is C18H19, C18H19NO3. This is a secondary base. Thebaine, on the other hand, when treated with HCl, concentrated HCl, gives you morphothebaine. And this is the tertiary base. Morphothebaine, a tertiary base. These particular reactions confirms the presence of, that is, in the formation of thebanine, a secondary base. From the tertiary one. This particular thing confirms only when the thebaine have the tertiary nitrogen. The tertiary nitrogen, when treated with the dilute HCl, gives secondary one. It never gives you again the tertiary. This above confirms the formation of thebanine from your thebaine. This particular reactions confirms the formation of, I repeat, there is a confusion. I'm sorry. Yes. The first reaction, I think you have understand the entire thing what I have written here. Morphine, codeine and thebaine, all the three alkaloids, all the three, opium alkaloid reacts with methyl iodide, one molecule gives methiodine. This confirms that there is the nitrogen what we have in the structure. Morphine, codeine and thebaine, all are tertiary nitrogen one. Further, morphine reacts with 140 degree under pressure, loses one molecule of water, gives you apomorphine. This is one molecule of water less as far as the formula is concerned. Codeine also gives the same. Since we are taken into consideration all the three alkaloids to elucidate the structure of morphine, this is the reason why we are taking the important points of your important reactions of all the three things to our conclusion is, our aim is to reach the final structure of morphine. And thebaine, when comparing morphine and codeine, both gives apomorphine. Thebaine, when treated with the dilute HCl, gives you thebanine. This is a secondary base. Thebaine, you know very well, a tertiary base. And the thebaine, on the other hand, treated with HCl, gives you morphothebaine, again a tertiary base. Tertiary gives you tertiary when treated with HCl. Tertiary gives you secondary when treated with the dilute HCl. these reactions, all these reactions confirm this conversion, interconversion is possible only when the nitrogen is connected with the cyclic structure. Else, if the nitrogen is only in this position, gives you this type of products, apomorphine, thebine, and morphothebine, etc. If the nitrogen is something like this one, if the nitrogen is connected to ring, all these reactions confirm the nitrogen is connected with the ring structure. If the nitrogen is like this, without ring, without connected with your cyclic structure, what we have in morphine, that is in particular the phenanthrene nucleus, that is a nucleus present in all the three alkaloids, then this might give you the primary base. Since we never get this primary base, we get only the secondary base, in some cases the tertiary base. And all these reactions confirms that the nitrogen presents only in tertiary position, nothing else. Nitrogen is tertiary positioned. The position, the nature of the nitrogen, what we have in all the three alkaloids are tertiary nitrogen. And further, the presence of cyclic structure, the presence of nitrogen, whether it is connected to with the phenanthrene, that is the cyclic structure. The cyclic structure, the basic structure, what we have in all the three alkaloids is your phenanthrene nucleus. Whether it is truly connected to your cyclic structure, we have further evidence. Codeine to take now to confirm the presence of cyclic structure. Nitrogen is attached to tertiary bases, whether we have really the cyclic tertiary base or not. Codeine, when undergoes exhaustive methylation, there is a specific reaction in organic science, exhaustive methylation, in which you are treating the alkaloid with methyl iodide and silver hydroxide, followed by heating this. You will get finally the exhaustive methylated product called exhaustive methylation. Codeine on exhaustive methylation gives you alpha codeine methyl. Alpha codeine methyl. This contains one more CH2 than codeine. Codeine gives alpha codeine methyl. This contains one CH2 extra compared to codeine. This is again a proof confirming that the presence of nitrogen is connected. That what we have the nitrogen here is cyclic tertiary nitrogen. And apart from this, there is one more reaction that confirms the presence of our phenanthrene nucleus. To confirm this, morphine, you go for a distillation of morphine using zinc dust. Morphine on distillation with zinc dust gives you phenanthrene nucleus and number of different types of bases. Remember, the main product what we reach now is because of the distillation of your morphine with zinc dust. One of the main product is phenanthrene nucleus. Phenanthrene, three-membered cyclic structure. As I have explained the structure of phenanthrene in the last class, anyway, I will write down, I will draw the phenanthrene structure here. This is your phenanthrene. This is phenanthrene. This phenanthrene we get we get once we go for distillation of morphine using your zinc dust. Morphine on distillation with the zinc dust gives you the phenanthrene nucleus plus bases. So this confirms that the phenanthrene is there in all the three opium alkaloids. Morphine, we have phenanthrene. Codeine, we have phenanthrene. Thebine, we have phenanthrene. Further, in morphine, The nature of OH, there are two OH groups, one is primary, another one is secondary. That we have confirmed using the different reactions. And the third oxygen in all the three alkaloids is in the form of ether link. And the nitrogen what we have in all the three is a tertiary nitrogen. Apart from this, the N is connected with only methyl CH3. For this, we have number of confirmative reactions are there that we have explained. And finally, we have reached a conclusion on the presence of phenanthrene in all the three alkaloids, morphine, codeine, and therein all the basic structure remains same in all the three. That is nothing but your phenanthrene. And based on this, the different points we have discussed both in module 1 and now in this part 2, we are arriving finally the structure of your morphine that we have drawn in the previous class. Please take a note of that particular structure. And with this, I am concluding the discussion on the structural elucidation of morphine. We will try to discuss the synthesis of morphine